Yesterday, Øredev was nice enough to give all the speakers a guided tour of Malmo, and I took the chance. I mean, if I have a session called a guided tour, and I have the chance to go with a professional guide, picking up tips, of course I did it. And it was also a chance for me to see Malmo. You see, I'm from the middle part of Sweden, which is not there, but there. And Malmo has always, to me, been something exotic south. From here, it's actually closer to Brussels, Amsterdam, or Berlin than it is to my hometown. My hometown, a smallish town in northern Sweden. Actually, I grew up on the countryside in a small village outside of that small town with 3 families in one village. Not very much to do until I got a computer and started programming, and I fell in love with programming, and I'm still in love with programming. I still think it's so fun and challenging and try to do it as much as possible. Now I moved and is what people consider center of Sweden, which is pretty far off from everything that matters. There I work as a programmer and architect on the .NET platform at a company consultancy called Cantor. And my main area of focus is security. So when ASP.NET Core was presented, I found out, yes, it's a new framework, new security, new things to learn. And I've, of course, looked into it, and that's why I'm giving this guided tour to you. Yesterday, one of the tips or tricks I picked up from the guide was that when you do a city tour, there is a kind of checklist. You see the library, the city hall, some churches, the harbor, a place with a nice view. So I need to have some kind of checklist also for this guided tour. And for security talk, a good checklist is the Owasp Top 10. The Owasp Top 10 from 2013 is a list of common security issues that are commonly exploited. Or rather, this is a blacklist of things you shouldn't do. It is released every 3rd year. And you may note that 2013 plus 3 is 2016. But since this is software related, the next release has been postponed until early next year. So we'll have to go with the 2013 version. So let's have a look. What is on the list? Number 10, invalid redirects and forward. Number 9, using components with known vulnerabilities. 8, cross-site request forgery. 7, missing functional level access control. 6, sensitive data exposure. 5, security misconfiguration. Number 4, insecure direct object references. Number 3, cross-site scripting. 2, broken authentication and session management. And number 1, the most common one, is injection. So we'll have a start to look at injection. What is injection then? Injection is, if for example you are doing SQL queries against a database, which most applications do. If you concatenate strings and build those SQL statements through strings and use part of untrusted user input, the user might affect the actual SQL statement that is executed against the database, which might include things like, I saw one on Twitter that was really good this morning. He had written on his ballot in the US election an apostrophe, drop table candidates, in an effort to erase the election and get it restarted. It obviously didn't work. So with SQL injection being the top issue, still decades after the technique was described, there must be a lot of remedies to it in a modern framework. So let's have a look at ASP.NET Core. What can it do against SQL injection? What mechanisms are there? Kind of none. Which makes sense if you look at a typical data access pattern in ASP.NET Core or any .NET application. You use link. This is the preferred out-of-the-box experience for data access. And if you have no SQL, there is no way to do SQL injection. Then I do know that there are things like Dapper, which is a popular micro ORM, where you do use SQL that you write yourself. But I know that that is not the default choice. for anyone even knowing about DAPA, you have to make an educated choice, which means it's probably people that knows about SQL injection as well. Because the most common reason for SQL injection is people that are struggling to just getting the SQL statements to work. They don't understand the necessity for parameterization. So SQL injection, they just built another structure that isn't vulnerable to it at all. And this is actually a pattern that comes back in ASP.NET Core. They've chosen ways of building and defaults that are secure to avoid the risky behavior. We'll have a look at what that means to authentication and session management next. The actual Owasp title is Broken Authentication and Session Management, but we'll have a look at how the authentication and session management work in ASP.NET Core. There is a law called Conway's Law. Anyone has heard about Conway's Law? Yeah? It states that any system built mimics the organization that built the system. So if you have an organization with 3 departments, you'll probably end up with 3 different systems that have integrations between them. If you have a team of 5 programmers, it's likely that you can end up with a system that is designed in 5 modules. When I looked closer to how the ASP.NET Core authentication story works, I found out it's essentially a blame game. So I would really like to know how Microsoft's corporate culture is. If they build a system that is a blame game, how do they do the blaming internally? Well, the proper name is chain of responsibility. It is a pattern that was first described in the Gang of 4 book back in the 90s. And a chain of responsibility means you have a number of modules that can each handle a request if it conforms to specific criteria. Another module might be able to handle a specific aspect of a request, even though it can't handle the entire request, and so forth. And each module does what it knows how to do. If it completed the request, it returns. If it didn't know how to complete the request, it forwards the request to the next module in the line. So simple setup of an ASP.NET Core application starts with a static file middleware. It will check if the request corresponds to a static file and then serve the static file. If it is not a static file, it will call the application cookie middleware. The application cookie middleware don't know how to handle a complete request, but it knows how to do one crucial thing for session management. It can pick up the cookie that is there in the browser, pick it up, verify it, and extract the user identity and attach that user identity to the request. So when the MVC module kicks in, the MVC module can check the user identity and use that for authorization and decisions on whether you are allowed access or not. Then, finally, you have a 404 handler, which is the end of all these chains. If none of the above knew how to handle the request, it gets forwarded to a simple middleware that just says 404 not found and returns. If we look at the authentication setup, typically when you first log in, the static file says, no, you're accessing the login page. That's not a static file. The authentication, the app cookie middleware says, no, there is no app cookie because you're yet not logged in. The MVC middleware says, well, this is a request for the login controller. Let's make the login, and you post back your password, etc. And the MVC controller then calls into ASP.NET Identity, which is a library that handles all the hard parts of user storage, password storage, user lookout, mapping identities, keeping track of roles and claims. All of that is built into ASP.NET Identity. Then ASP.NET Identity makes a callback to the application cookie middleware and instructs it to set a cookie to remember the identity that we just established for forthcoming requests. We'll also have a look at briefly just at the default template. If you create a template out of the box, file new project, you will get this, where you have static files, an external cookie which is used in the flow when you, for example, authenticate with Google, Facebook providers. The app cookie external authentication middleware, MVC, and the 404. If you do log in with, let's say, Google, then the external authentication mechanism will handle the Google authentication, save that as an external identity in a separate instance of the cookie middleware to make sure that we remember the Google identity. But the Google identity is not the identity we want to use in the application. So in the next step, ASP.NET Identity picks it up and maps the Google login you used to the identity in the application and sets the application cookie. This is kind of my favorite area within security or development in general, so I could talk for a very long time. I don't have time to talk much more about it right now, but I have a deep dive session tomorrow where we will go deeper into this. I'll show some code how to configure this in various ways and how to implement a simple middleware. Before we're leaving authentication, I'd also like to mention Identity Server 4. If we have a web application, it's a simple web application, right? But nowadays, web applications are hardly that simple. They are 3 applications often. You have some parts that run as MVC applications on the server. You have some parts that you are utilizing Angular or something similar to write an in-browser application in JavaScript. And that one calls a REST API in the backend. So really, you have 3 applications, and they have different authentication requirements. We'll get back to it with cross-site request forgery, why you shouldn't use cookies for the REST API. But if you have several applications, you want single sign-on. So that's where Identity Server 4 comes into play. You delegate authentication to Identity Server 4. Each of the other applications can use their respective mechanism to verify the identity against Identity Server 4, but the user experience is just a single sign-in page. What's great with Identity Server 4 is also that it is in itself a middleware, so you can embed it into your application. It can handle local accounts, username, password. Identity Server 4 can also handle federated or external authentication, Google, Facebook, SAML2, which is used in enterprises, is nearly done. My intention was to have it done, the middleware I'm working on by now, but I'm not done. I hope late November. So let's move on from authentication. For now, I'll get back tomorrow and look at number 3 on the Owasp list. Cross-site scripting. Cross-site scripting, it can be, for example, a comment functionality in a blog where users can write comments. And if you write a comment that contains a script tag and the application is not properly protected, that script will run. And I'd love the possibility to run a script that I wrote on someone else's web page, because a script can, of course, do anything to the page. So the classical remedy is to cross-site scripting is to always remember to escape content and to HTML escape it. So let's see what happens in ASP.NET Core, and this is not new to Core, it's been the same with MVC and Razor before. If we just echo out a string containing a script tag inside some P tags, I want to have it pretty formatted. What happens? Well, it shows up displayed exactly with as I wrote it, which means it has been escaped on the way out, because Razor HTML escapes by default. So you actually have to opt out of the HTML escaping. If you for some reason has pre-formatted HTML in the database that you want to echo out to the from the database you want to echo out to the web page, you have to actively say that this is already HTML, don't escape it again. And that's one more case of ASP.NET Core being secure by default. You don't have to think about escaping because it's done for you. Number 4, insecure direct object references. So what is this? If I place an order for a book, I might get a confirmation email with a link to my order, so I can check my order. That link is a direct object reference to my order. if I try to change that number to 17 and try to enter it, would I get someone else's order? If it's properly built, no. In some cases, yes, I would. But this brings us to the issue of authorization. And here it has been a vast improvement with the ASP.NET Core to the authorization story. Previously, when going to talks about security in ASP.NET, if you have a 40 minutes talk, it's been like 35 minutes authentication, how to get the user logged in. And then they have one slide where it says authorization, and on it says, oh, you know who the user is, just check, remember to access check. Time for questions. Because the authorization story was fairly thin, and they reworked it. Now there's a lot more support for different scenarios. Still, we have the simple authorize attribute, which you can decorate a controller or action with, and just says, you need to be logged in. No matter who you are, as long as you are logged in, you're allowed to see this. Which makes sense in some cases, or for internal systems maybe, where you don't have such fine-grained access control. It's just that you are logged in or not that matters. In many cases, you want to distinguish users. You can do that with role-based security, the classical roles equal admin. But you shouldn't do that in ASP.NET Core. There's something better. There's policies. So let's say policy equals admin. Because if you use the roles attribute, authorizing roles, you've littered your code. Every single action in the code base that requires administrative access has knowledge of the details of the rule, that you are allowed to access administrative stuff if you are in the role admin. If you later would have to change that role and say that, no, we need to, if you are a manager, you are also let in, even though you don't have the admin role, you would have to go all over the place to all those places. It doesn't add it. If you instead use a policy, we define the policy centrally in code. And this policy says exactly the same. It says that we have a policy called admin, and that policy requires that you have a claim of type role with the value admin. They are equivalent, but this is more flexible because you've brought the knowledge to one place. It can, of course, get more complex. If you go all the way, you have policies, requirements, and handlers. Let's see an example. You need to be over 18 to buy alcoholic beverages in a store in Sweden. That can be expressed as a requirement. You need to be at a minimum age of 18. And the requirement can be checked by a handler. And the handler is a minimum age checker. That doesn't make much sense, but if we have a more complex requirement. I usually work for the healthcare sector. And let's see about medical journals. My medical records are about the most sensitive data that I have, even though I'm a bit scared from the keynote this morning that what I do in social networks might tell more about me than my medical records. But I still want my medical records safe. So, what is needed to read a journal? Well, first we have a requirement that you need a smart card login. In Sweden, it is not allowed to expose medical records to healthcare professionals if you just log in with username and password. You need a stronger authentication mechanism. That can be checked by a handler that verifies that the current login method was a smart card. For example, a doctor might have a system where they can log in conveniently with username and password to just see the schedule without names of the patients. But with a smart card, they do get to see everything. Then there's another requirement that you have a patient relationship. You may not see medical records for anyone, just for those that you are working with. And that might be fulfilled in two ways. Either you have an existing relation, or it's the emergency room. If I come in knocked out to the hospital, yes, it's fine if they access my medical records to see if there's something special they need to know before treating me. And this is where you have the advantage of splitting it up in policy, requirement, and handlers. The policy is simple to reference. The requirement says the rules, and the handlers validates the requirements. And you can have a mechanism where the handlers, they vote. They can say, no idea. They say, definitely yes, definitely no. So you can have multiple handlers, and it is enough if one of them says yes and none says no, and you get the access. So it is a powerful system. Choose the level you need. This is really powerful, but I wouldn't do it for an application unless really needed, because it gets complex. Let's move on then, or rather back to our shopping order example, because I've still not solved this issue. Because so far we've been talking about attribute-based authorization, which lacks a fundamental feature of most systems. To see if I can access that order, I first need to load the order and check who placed the order. I can't just do the access decision based on the request. I need to load some data, which means I can't use an attribute. I need to move into code. And that's possible as well. From code, I can call the policy evaluation through an authorization service. Use the authorization service and check, do I have access according to the show order policy? Then I have to either return the view with the order or a challenge result. The challenge result is then picked up by the authentication, the cookie middleware, which checks, either prompts me to log in, or if I am already logged in, says, no, you don't have access. And the policy, just an example of how it works. I'm adding a policy, require assertion. An assertion is a function that must evaluate to true in order to allow the people to have access, and it's a simple condition. I check, are you in the role employee? Then you can see every order. If not, I check that the owner property of the order matches the name identifier of the current user. That's also a small tip, that when you are saving or persisting the identity of a user, use the name identifier property. It's a unique key. It's a primary key of the user. Don't use the email. Don't use the username. Those can be changed. But keep to the name identifier. So, leaving for a while the matter of direct object references, we'll have a look at one more issue of authorization. Because if I have an order and I have an edit button, I might allow, I of course need to check when I do the post back to the edit action that the user has access to update that order. But it makes sense if the edit button is only visible to those users that do have edit access. And here I can use the same policy from my Razor view. I can inject the authorization service to the Razor view, and then I can call that policy. So I never risk getting those out of sync, because it's so frustrating for a user if the edit button exists, but you're then denied when you try to use it. So to summarize authorization, we have the simple authorize attribute, which you can attach a role or policy to. We have the full-blown policy requirement and handler mechanism. We have resource-based authorization, and we have views. It's a huge toolbox compared to what we had before, and pick the parts you need. Don't go all the way to policy requirement handler unless you really need to, because it can get really, really complex. So, any questions so far on authorization before we move on? Great. Let's move on. What I learned also yesterday on the guided tour is that a great guide talks and shows things all the time. It's a high tempo, and ASP.NET Core is no different. There's so much to squeeze into 40 minutes. Security misconfiguration, number 5 on the Owasp top list. What is that? Well, this means that you might have unnecessary features which are enabled that shouldn't be there. There might be default accounts or passwords, or unsecure default settings. ASP.NET Core is better than previous generations here because of how the setup works. Previously, you had to go through the web config and the inherited machine config and stuff to know what HTTP modules were really loaded. You probably had a role provider being inherited and injected in most applications, even though you didn't notice. And is that one updated and secure? Here, you have to deliberately say exactly what the application can do. It won't even serve up static files unless you tell it to use static files, which is good. Consider, for example, you have an application that serves files through an MVC action. That MVC action does the access control, and if you're allowed, retrieves the file and sends it back to you. What good is it if you accidentally expose the entire file storage directly through the web server? There's no risk here. Number 6, sensitive data exposure. In an application, we have sensitive data that need to be guarded, both at rest when stored and in transit when transferred over the network. The most common example that you have in many applications is probably password storage. To write a correct, secure password storage is extremely hard. So use ASP.NET Identity or a similar well-known framework. Identity 3 uses an algorithm called PBKDF2, password-based key derivation algorithm, something, with 1,000 iterations. That's a decent trade-off between speed at the login, when you do the login, and speed, or rather lack of speed, if someone uses a graphical card-powered password cracker when they get access to, if they have got access to the database. Another thing is to ensure that you have TLS. This will require HTTP as attribute you can apply to controllers and actions to make sure that it is accessed only through TLS. I wouldn't use this because it's much better to just make the entire application only available over HTTPS. But if for some reason you cannot do that, speed is not an argument anymore. It's probably, in some cases, faster using HTTPS because some mechanism for caching works better or connection reuse works better. But you might have insecure resources problems. Then you can use require HTTPS. There's also another mod thing that is in the library, and this is more of an advanced topic, called data protection. If you want to store some data on the, in a cookie in the user's browser, or you want to store some data in a hidden form field because you need it later on, some correlation data, you're making a wizard of some kind and want each step is a form. You need to store the results of the previous steps, which might contain sensitive data. There is a data protector where we can take source string, hello world, we can send it through the data protector, it comes out as gibberish, and we can just unprotect it and get it back. This takes care of the both encrypting and signing data. And it also has something called purpose. To use data protection, we inject a data protection provider through the dependency injection system, and then you create a specific data protector for each place where you need to use it, where you provide a purpose. Why that? Well, if we have, for example, an application that has two places to use the data protection. One is the form I mentioned, where we have some state saved in a hidden form field. The other one that uses data protection is actually the cookie middleware. The authentication cookie is just a serialized version of all the claims on the user that are then run through the data protector. What if I can affect what is stored in that form field? So I store Anders is admin. And then in my browser dev tools, I swap them. So I take this string that came out that I know says Anders is admin and put that as the authentication ticket. Then I would gain access to the system. That's why you should have a purpose, because it checks that when you extract and unprotect data, it checks that the purpose still matches. So thanks to the purpose, if I did such an attack, the authentication cookie middleware would just say, no, this is not something that was encrypted with the purpose of being a cookie. Forget it. The API is simple, protect or unprotect. Maybe more of an advanced feature, but it is there. Next on the Owasp list is 7, missing functional level access control. We've talked about authorized attributes, so just a reminder really. Next up is cross-site request forgery. So I'll see if you've paid attention and remember what mechanism are we using for preserving identity across call. I have a giveaway, if anyone can tell me what it is. Cookies. Who was first? This gentleman over here. Here you go, some cookies. Cookies. Well, some properties of cookies, they are delicious. And I'm sorry to say this now, but they are bad for your health. From a programmer perspective, they are simple because they are auto-transmitted. And they are bad because they are auto-transmitted. They are sent with every single request to the server. So why is that bad? Well, there was a couple of years ago, a major broadband operator here in Sweden had a cross-site request forgery issue with their routers. These routers played at thousands of homes. If you were logged into that, had logged in at one point, you could still be remembered as logged in. Then any page on the internet that you visited could contain a hidden iframe containing a form that auto-posted to the management interface of that router, changing the DNS settings. And I mean, a bad person would struggle hard to create a phishing email to get people to click on a link and visit a web server of their choice. It's much easier if you control the DNS. You can send people off to whatever server you want. So to remedy this, we must make sure that the posted data actually originated from a form on the same application. And that's simple. You just create a token containing a cryptographically secure random component tied to the current user. You encrypt it, you sign it, you put that in a form field, you put it also in a cookie, and on receiving form post, you have to validate that the tokens still match and are equal. You check the signature, decrypt it, and check that it still is the right user that is logged in. Or you just apply a validate anti-forgery token attribute to your controller or action. You no longer even have to explicitly add this HTML.anti-forgery token stuff, because the tag helper for the form element in ASP.NET Core does that for you, as long as you link to an action. So if you are using the built-in mechanism for linking to an action, it's just a simple attribute to remember. Then it is a matter of applying it wisely. And I'd say anything that alters any kind of data, which is a post, use a validate anti-forgery token. Number 9 on the list, using components with known vulnerabilities. This is really, regarding the framework, .NET framework, been a no-brainer for us developers, because we can trust this, Windows Update. And it has been the headache of the system administrator to make sure that Windows updates are scheduled. Now we go into how an ASP.NET Core application can be run. It can be run on the full framework, then it's still the system administrator. It can be run on a shared instance of the .NET Core framework, then it's still the system administrator. Or you can have it self-contained, such as when you're running on Linux or Mac. You install the framework components you use with your application, which means you are responsible for keeping it up to date. You are responsible for checking if there are any new releases and make sure they find the way to all deployed applications. There is a mechanism, though, in Windows Update that they can find all instances of the .NET Core framework and do patches. But Microsoft has said that it will only do that for severely critical issues, so I wouldn't count on it. But, well, this doesn't really matter because you're using other packages, aren't you? And there you're still responsible. If you're running A hosted application is quite simple. You just make sure that you update. But if you're distributing this to customers' machines, you might have hundreds or thousands of instances installed that customers have installed several years back. How do you get the update? And that's something that you really need to consider. What is the update and security patching story for any kind of code that you distribute? And it needs to be part of the original architecture. Number 10 on my list, or the Owasp list, is invalid redirection forwards. This is, well, we can take an example here too. I'm sending a phishing email with a link where I want someone to enter their account details. I've got quite a few from Nordea, a bank, even though I'm not a Nordea customer, that asked me to enter my Nordea bank details. Telia, the major phone operator in Sweden, I've also got false invoices from them. If you have an invalid redirect, you can make it even, well, less easy to detect, or even naughtier. You can send a phishing mail which contains a link to where you should log in on the real site. Then you log in on the real site. And then after login, you're redirected to the bad site, where you're asked to enter credit card details, where you're asked to, or if there is a cross-site request forgery vulnerability in the site, this can be combined. So you can just on that bad site issue a cross-site request forgery attack back on the real site, because now you know the user is logged in. It's perfect. You don't have to make it blind and hope the user is logged in. You know it. What's really bad here is that, I mean, the URL could be to the right site. We've trained the users to check the link you click. It is the right link. We've trained the users to before you enter the password, check the certificate, check the green bar. It is the right site. Even though you check the certificate, it says you are on the right place, because you are on the right place. But then the return URL points to a bad site. Fortunately, ASP.NET Core is secure against this. There is a handy method called url.isLocalURL that can be used to check if a certain URL is local. And it takes into account things like relative URLs, a complete URL, does it match the host and scheme, well, whatever. It's as anything related to security, once you dig into it, there are so many details. And all is wrapped up in this, and the default account controller makes use of this before it issues a redirect. So to finalize and summarize a bit of ASP.NET security, it is secure by default. You have a link for database access, which means SQL injection isn't possible. You have HTML escaping by default to remedy cross-site scripting. You have to opt out of it. And you only activate the needed components in the startup. There's an authentication pipeline that is really powerful. You can mix and match in different ways. Well, middleware, you have ASP.NET Identity 3, which is improved compared to the ASP.NET Identity 2 version used with these Microsoft.OWin packages. They moved a lot of functionality into the library, so the account controller is not that terribly large anymore. We have Identity Server 4 for more complex requirements. Authorization story is a lot improved with the policies, data protection, and the anti-forgery token mechanism, which is also improved.